So now if we consider that this beam is supported on two different support, then I can say the load of 35 kilonewton is acting on an entire beam. So according to that, as it is on a mid span and it is supported by two different support, I can say that the load of 35 divided by 2, what it is? So that will be 17.5 kilonewton. So what amount of load will transfer from point 1? It will be 17.5 kilonewton. And same 17.5 kilonewton load will transfer from column 2. But although this was a very simple numerical and it was used to make you understand that what will be the effect and how we can calculate the amount of load that is transferred on both the support. Now, in actual form, this is not the amount of load that is transferred, but it is the reaction that is being created due to this 35 kilonewton of load. Let me elaborate this. Suppose this is a beam and that beam is supported on two supports, right? Now what will happen? This beam will exert some load to this columns and this column will resist it. It will resist, or I can say it will react to the force. So that reaction was 17.5 kilonewton. It was not a load that was transferred, but it is a reaction that was being created. Now why we are calculating this? Because on this calculation we can find out that our column should be strong enough to bear this amount of load. So we are going to design that column according to the load that we procured over here. The amount of load that we have procured here. So this is the first step of designing any member. Now when it comes to this kind of simple numericals, it's really easy. We can say what it will be. Then I can say it will be reactions at point A and at point B is equal to total load divided by 2. So this was RA and I can say this is an RB. And this is a total load because there is no other load acting on this beam. So what I did, total load divided by 2 because there are two numbers of support over here. But what if the numerical is somewhat complex? So let me say that you have two numbers of load acting on your beam. One is at 1 meter, another one is at 2 meter, and again this is 1.5 meter. This load is of 10 kilonewton and this another load is of 25 kilonewton. Now what you have to do is you need to find out the reactions. So let me say this is point A and this is point B. So you need to find out the reaction at point A and at point B. Now in this type of conditions, what you are supposed to do is you need to use equilibrium condition. Now what is that equilibrium condition? The equilibrium condition says anti-clockwise moment is equal to clockwise moment. Now how to understand which moment is clockwise and which moment is anti-clockwise. So for reference, I'm using this clock over here. Now, if I take a reference point at A or at B, then let's see what is the effect of load and how the moment take place. Now, if I am taking the reference at point A, then what I need to do is I'll pinpoint at A. Right? I have pinned it at point A. Now, which are the loads acting on this beam? So this is the first load. It is going downward. So moment created was clockwise because this clock is working like this, right? So this moment was clockwise. Again, due to this load, which is of 25 kilonewtons, what happened? A moment was again a clockwise. And for a last one, that is a point B. At point B, it is acting upward and it was in the opposite direction to this clock. So it is an anti-clockwise moment. Okay, so when it comes to a moment, first of all, we need to understand what is moment. For moment, we have a formula. Moment is equal to load into distance. Where L is equal to load and D is equal to distance. Now, if I would like to make you understand what are the basics of moment, then let me elaborate that. If we are talking about a door, right? This is a plan view of door. Here it is hinged at this point. Now if I try to open this door from here, it will be really very easy. For me to open the door from here. Why? Because the moment is huge at this place. Now let us understand what it happened. Now this was a load. I can say this is a load applied by me or applied by you on door. And this is the distance from the axis. So here the moment will be L into D. But what happens if I apply a moment from here? If I applied a load from here, that is at D by 2. Let me say this is at D by 2. Now let's see what will be the moment if I apply a load from here. So moment is equal to load into distance. Load is as it is. I am not changing the amount of load, but the distance changed. This distance was D and now it is D by 2. Now it is D by 2. So now the moment which is generated due to this load will be half of the moment generated by this load. Right. So distance plays a vital role when we are counting a moment. So as the distance is more, the moment increases. And this is a basic concept of moment. Now, when we are calculating any numerical, what we are going to use is load into distance. That is our basic formula. But this is the basics of moment. That what happens with moment and how it increases with a length and how it decreases with a length. So this is the basics of moment. Now let me take one example that is different from what we have seen previously. Now, let me say this is a 15 kilonewton and this is a 25 kilonewton of load acting on a beam. Here it is 1 meter, here it's a 2 meter, and here it is 1.5 meter. Now my first step should be from which point I'll take a reference to calculate a moment. It could be at point A also and it could be at point B also. It doesn't make any difference. You can take a moment from point A, rather you can take it from point B. It doesn't make any difference. But for this numerical, I am taking moment at A. So what does it mean? It means that I am taking A as my reference point. So let's see in this entire system how many numbers of forces are here. I can say this is the one force, this is force number 2, and this is force number 3, and this is force number 4. So now for each and every forces we need to calculate a moment. So here we need to calculate moment for 1, for 2, for 3 and for 4. We have 4 number of forces and we are going to find out a 4 different moment. Now let's see. Let's start. Now as my A is my reference point. So when I want to find out a moment for A point, what happens? Let me show you. For this A point, what happens? Moment is equal to load into distance. Although this load is unknown for me, so I'll keep it as RA, but the distance is 0. So the moment at A will be 0. Thus, we don't take in a calculation. We don't take this in a calculation. The point which we take as a reference, we does not take it in a calculation. So what does it mean? It means that we are not going to take this force into calculation. So what we are going to take in a calculation is a force of 15 kilonewton, force of this is 20 kilonewton, force of 20 kilonewton and a B, I can say RB, right? So now once this is clarified, this is 20 kilonewton, as it is not visible, I can say. Our second step should be using a equilibrium conditions, equilibrium formula. So it is anti-clockwise moment is equal to clockwise moment. So it's quite easy. So now we will see with all the different loads what happens. Is it in a clockwise direction or in a anti-clockwise direction? But for this I'll use a clock for your better understanding. Now if I took A as my reference point, then what I'll do, I'll keep my finger over here to pin it. So I have pin joined my beam. Now let's say I'll not take this A in a calculation because I told you why I am not going to take it in a calculation. Now from this point, it is a load of 15 kilonewton. How does it goes? It goes downward. And which type of moment is this? This is a clockwise moment, right? See, this clock is working on that moment, that type of moment. Okay. Now what about the load of 20 kilonewton? Now this 20 kilonewton of load is also working in a clockwise direction. So what happened? I can say the 15 kilonewton was in a clockwise direction plus a 20 kilonewton of load was also in a clockwise direction. Now what does our equilibrium formula says? That it is a clockwise moment. Now moment is equal to load into distance. Now from where we are supposed to take all this distance? All the distance should be taken from point which you have taken as a reference. Here what we have taken as a reference is point A. Here I have took point A as a reference, so all the distances will be taken from point A. Now for 15 kilonewton of load, this distance from point A to the load is of 1 meter. So what I am supposed to do is, this is a load and distance is equal to 1. Now for this 20 kilonewton of load, the distance from point A to the 20 kilonewton of load is 1 plus 2, that is equal to 3 meter. So this will be into 3. Now one more load is remaining, that is RB, which is acting on upward direction, and that is again I can say a anti-clockwise moment, because a clock goes down to up, not up to down, right? So this will be written over here. So what is the load over here? That is RB. It is unknown to us. It's RB. And distance, I can say from A to B. What is the total distance from A to B? Because A is your reference point. So all the distance are taken from point A. Now when I talk about point A to B, the distance is 1 meter plus 2 meter, that is 3 meter, plus 1.5 meter, that is equal to 4.5 meters. So total distance will be 4.5 meters. Right. Now you need to find out RB, that is unknown. Now to find the RB, 4.5 RB is equal to 15 plus 60. Right. So that is equal to 75. Right. So 4.5 RB is equal to 7.75. Then RB is equal to 75 upon 4.5. Just calculate the answer. Your answer is 16.66 kilonewton. So what I can say is, I can say that from both of this support, which is A and B, a 16.66 kilonewton of load is transferred from point B, then remaining load will be transferred from point A. So what we need to find out is, we need to find out the total load on this beam. So I can say, what is the total load? I can write it like this, that all the load transferring from A plus all the load transferring from B is equal to total load on beam. So for this I can write RA is equal to total load minus RB, which is equal to, what is the total load? 15 plus 20 minus RB, that is equal to 35 minus 60.66, which is equal to 18.3 kilonewton. So what you procured is RA. Now you have two values over here. One is your RB and another one is RA. So I can say RA is equal to 18.3 kilonewton and your RB is equal to 16.66 kilonewton. Right?